Hello. Here is the presentation of Dr. Zacher. Dr. Zacher presents the new revolutionary concept of the closed-loop control, which is called data stream management. The closed-loop control was first proposed in the 17th century and since that has achieved many convincing great results. But its actual state differs from the today's automation. The main differences are shown in the book of Dr. Zacher. Modern against classic. Is it possible to describe the closed loop with modern automation tools? The answer is given in the book of Dr. Zacher. The first concept is the bus approach.
The second concept is called data stream management.
The third concept is called climb and hold. According to this concept, not the controller alone will be used for all kinds of closed-loop behavior. The data stream manager will control the loop. The fourth concept is the Terminator. It is a new tool, a wonderful, universal and magic tool. Finally, there is the Antisystem approach, which could be used not only for feedback, but for the wide range of dynamic systems. It was the overview. Now we will show you all 5 solutions one after another. We begin with the bus approach. Your attention please. Very important feature of the bus approach is that the mathematical description is the same as of the classical loop. The bus approach has more advantages against classical loop. The design of high-dimensionality systems is clear and easy. With the bus approach, it is easy to reconfigure the bus from signal to signal, as it is shown by an example of 2 signals. Modern against classic. The data stream manager, combined with the bus approach, is a new, revolutionary concept of the closed-loop control theory. Data stream manager are a kind of software agents, which are widely known in informatics. But a data stream manager consists not only of programmed logical operation, but also of usual transfer functions. Here are shown only 2 examples of data stream manager, the override manager and the ident manager. Modern against classic.
Each student, who have studied basics of the feedback control, knows that a closed loop has 2 kinds of behavior. The set point behavior and the disturbance behavior, which are controlled from one controller alone.
As far as a controller will be adjusted optimally for set point behavior, it cannot be optimal by disturbance behavior. The idea of this solution, which is called climb and hold, is to change the point of view and to control each behavior not with only one block, but with its own block. A data stream manager surfer is developed for the climb. What needs a real surfer? The answer is, he needs many small waves. If there is only one wave, then the controller is fixed for this wave. But what happens, supposing the wave's parameter do change during control? The surfer will not achieve his target or will achieve it not optimal. Another situation is if there are many small waves. You can follow yourself how moves the surfer from initial point to the target when there is not only one set point step, but many small steps. A data stream manager Terminator is developed for the hold. The Terminator practically fully destroyed any disturbance, independently of the place where the disturbance is applied. The use of both managers of the surfer and of the Terminator leads to significant results, which were not known before by the control of closed loops. The same data stream manager Terminator could be performed a little and could be used by plants with changeable parameters and by nonlinear plants with different operating points. That's why the Terminator is called Plant Bodyguard. The data stream manager Plant Guard don't allow any changes of plant to influence the control. The Terminator and the Plant Guard are so simple build and the results of their implementation are so much convincing that one can only wonder why this data stream manager were not used many years before. Here is an example of a linear time variant plant with dray sets of parameters by different times, by 0, 5 and 30 seconds. Note please that step responses are the same, although the controller has all the time the same parameters, which is not possible by classical control. Modern against classic. Finally, we present you the antisystem approach. Dr. Zacher had derived and verified that a system could be fully compensated with its antisystem without building an inverse of the original system. There are so many publications about antisystem approach that we will only show you 2 examples.
First example is the acceleration of control with Turbo Data Stream Manager. The second example is the optimization of control with Bypass Data Stream Manager.
Modern against classic. That's all. Follow us by books, website and YouTube presentations. Thank you for attention.